Yes, friends, and welcome once again to our class. And as you all know that our laptop was not working properly all these days, so that's why I had to teach you to with the help of tablet. Just let me make sure once whether the recording is on or not. Yes, the recording is on. So let's start our work. So friends, my laptop was not working properly. That's why I had just taught you with the help of my tablet all these days. But believe me, from now on the classes will be regular because the laptop is back to normal now. I had called the repairer and he came to my home and he repaired the laptop. So let's start. So in the previous class, we had learnt about formats principle. The applications of formats principles we were learning. Okay, not principles, principle. So formats principle had very great applications in optics, and one of the great applications is this also. This is the last application, by the way, last application of formats principle. So let's study this last application, which is thin lens formula or lens makers formula. Now there are basically three type of formulas over here. Okay, three type of formulas are there. One is this, which you can see on the screen. This is what? This is thin lens formula or lens makers formula. Okay, this whole formula is what? This is thin lens formula or lens makers formula. The next formula, which is this is called as lens formula. Just remember this thing, that this formula is called as lens formula, and this formula is either called as thin lens formula or either called as lens makers formula. So both are different, both do not imply the same thing. Okay, both are not same, both are different, so you have to remember this thing. So let's understand the meaning of various terms involved in this particular thin lens formula or lens makers formula. Okay, where this f which you had seen in the previous slide, this f which you can see with the help of laser, this f is what? This f is basically focal length of the lens. Okay, this f is basically your focal length of the lens. Now n, what is n? Small n, you can see over here, it is a small n. Okay, so what is small n? Small n is the refractive index of the lens with respect to the surrounding medium. Okay, now you will have to understand this with the help of figure. So here is the figure. So here is your lens. This area is this is the volume occupied by your lens. Okay, this complete area is occupied by your lens. Okay, so let's undo all this stuff. Yes, so this particular area is occupied by your lens, and this particular area is occupied by your lens, and this is the surrounding medium of the lens. Okay, this is the area which is the surrounding medium of the lens. This area and this area, these are surrounding medium of the lens. So n is the refractive index of the lens with respect to the surrounding medium. Okay, it is the refractive index of the lens with respect to the surrounding medium, which I had shown to you over there. R1 and R2 are radius of curvature of the two surfaces of the lens. R1 and R2 are what? They are radius of curvature of the two surfaces of the lens. Now let us understand the meaning of this. Suppose this is your surface number 1, this much. Okay, this is your surface number 1. Suppose from here till here, this is your surface number 1, and from here till here, from here till here, this is your surface number 2, and this is your surface number 1. Okay, so what happens is that when you try to complete this the circle of these two things over here. Okay, when you try to complete this circle, the circle formed by this first surface, okay, it will be something like this. Okay, so in order, why are we completing the circle? By the way, because we want to find out the radius of curvature. Okay, so that's why we are completing the circle. And similarly for this surface also, there might be some circle, some imaginary circle, of which this particular part of the lens is an arc of that circle. Okay, so this is your, that blue circle and green circles are the two circles which you might see over here. and R1 and R2 are the radius of curvature, means the radius of this green circle. Okay, radius of this green circle is what? Radius of this green circle is R1, and radius of this blue circle is what? Radius of this blue circle is R2. Okay, that is what is meant by the radius of curvature of this first surface and second surface. This is the meaning of that. Okay, so let's go back to our point. Okay, R1 and R2 are radii of curvature of the two surfaces of the lens. Okay, radii of curvature of the two surfaces of the lens. And this is your basically thin lens formula, which looks something like this. That is 1 upon focal length of the lens is equal to n minus 1, where n is what? N is the refractive index of the lens with respect to the surrounding medium. Okay, refractive index of the lens. Okay, let's understand. Refractive index of the lens with respect to surrounding medium. With respect to surrounding medium. Okay, this is inside this there is material of the lens, and over here there might be air, or if the lens is immersed in water, then there will be water surrounding the lens. If the lens is immersed in wax, then there will be wax surrounding this lens. Okay, so those are the things. So In is equal to your refractive index of the lens with respect to surrounding medium, and R1 and R2 are the radii of curvature of the two surfaces of the lens. Okay, so these are the things, and this is your basically thin lens formula, or you can also call it lens maker's formula. But note that this is not lens formula. Okay, note that this is not lens formula. Just note it down in your notebook. This is not lens formula. If we talk about only lens formula, then which formula will come? This formula will come. If we talk only about lens formula, then this formula will come instead of that. Okay, this formula will hold good then. Okay, so these are the things which you have to take special care about. So R1 and R2 are radii of curvature of the two surfaces of the lens. 1 upon V minus 1 upon U, 1 upon V minus 1 upon U is equal to 1 upon F, which is your lens formula. Okay, now let us assume in our figure, that this capital L, what is this capital L? Capital L is the a thin converging lens in air. Okay, we are considering the capital L. What do we consider capital L? Capital L is being considered as the lens over here. This complete lens is a converging lens. Okay, what is this complete lens? It is a converging lens. In this particular derivation, you might also take diverging lens if you want to take. Then you can also take diverging lens in this particular problem. Okay, no, it makes no difference. It makes no difference whatsoever. Even if you take a diverging lens over here and prove with the help of diverging lens, it does not make any difference. Okay, but for our convenience, because the straightforward things are always unusual things are very inconvenient for us. Okay, unusual things in life are very inconvenient for us. For example, if it would have been a diverging lens, then what would happen? Suppose if it would have been a diverging lens, then a situation of this kind would have arisen. Okay, a situation of this kind would have arose. So in this particular situation, your paraxial ray will come like this. This is your axis of the lens. Your paraxial ray will come like this and will diverge from here. Okay, it will diverge from here. Similarly, another paraxial ray will come from here and will get diverged from here. So a virtual image will be formed, not a real image. Okay, a virtual image will be formed over here. Okay, over here a virtual image will be formed, or a real image will not be formed in that case. In that particular case, no real image is formed, only virtual image is formed in that case. So that is an unusual case. That is what? That is an unusual case. That's why we are taking converging lens in order to prove our situation. And if we prove it for converging lens, then it will also apply to diverging lens by common sense. Okay, so just not to overcomplicate our situation, we are basically taking converging lens. Otherwise, if you want to take diverging lens, and make the things complicated for you, you can take it, no problem. Okay. So what is your capital L? Capital L is a thin converging lens in air. In air, okay, we are considering in air. Okay. Now right now we had learned this, that refract n is equal to refractive index of the lens with respect to the surrounding medium. And what are we taking the surrounding medium to be? We are taking the surrounding medium as air over here. For our simplicity, we are taking the surrounding medium as air. So if someone says that n is the refractive index of the lens with respect to the surrounding medium and the surrounding medium is air, then that just means that refractive index with respect to air, refractive index of the lens with respect to air. Okay. And if refractive index of the lens is taken with respect to air, then this value of n will be small n, right? So it will be absolute value, because refractive index of air is equal to 1. Okay, refractive index of air is almost equal to 1. So if we are taking with respect to surrounding medium and the surrounding medium is air, then with respect to air, that is with respect to 1 we are taking, so n by 1 will come. So n by 1 will come in the expression, but n by 1 will simply mean that it is equal to 1. So n is your refractive index of the lens with respect to the surrounding medium, but your surrounding medium is air. So that's why it is equal to the absolute value of refractive index of the lens. Okay, the absolute value of the refractive index of the lens, whatever its value will be, the same will be with respect to surrounding medium, because we have taken the surrounding medium to be air. That's why. Okay. So this is a thin converging lens in air. CD is negligibly small over here. N is refractive index of the material of the lens. Okay. CD is negligibly small. Let's see over here. What is CD? This CD means the thickness of the lens at its maximum. Thickness of the lens at its maximum. Okay, this is the maximum thickness of the lens. This is very small. This formula does not hold for very big lens. For example, in some NASA telescope, for example, some NASA telescope might have very big lens. Okay, some NASA telescope, if it wants to see the celestial bodies at a very great distance, at very light years apart. So in those telescopes, NASA telescopes, those are giant lenses. Okay, those are giant lenses. So in those particular lenses, you cannot basically apply this formula, because this formula is for small lenses. Small lenses means very small lenses. Okay, means the one which you have in your spectacles. Okay, the lens which you have in your spectacles, that will fit into the category of small lens. Okay, because that is small in size. So your spectacle lens or goggle lens might be fitting into the category of small lens, but your James Webb telescope, that lens of James Webb telescope or any other telescope of NASA, those lens will be very huge in size. Okay, those are so huge in size that they are even larger than buildings. Okay, their lenses, the lenses of such telescopes are even larger than the buildings. So in those lenses you cannot apply this thin lens formula. Okay, this approximation will not hold good over there. So in order to tell that our lens is small, we have taken that this CD is small. Okay, so let's see over here. CD is your negligibly small. Okay, n is equal to refractive index of the material of the lens with respect to air, means with respect to the surrounding medium, and the surrounding medium as it is air. So the refractive index of the material of the lens, and with respect to surrounding medium, even if you say or if you don't say, it doesn't matter, because air has a refractive index equal to 1. So refractive index of anything with respect to air will be the refractive index of the material itself. Okay, so n is equal to refractive index of the material of the lens, and r1 is equal to radius of curvature of the first surface. I told you just now. R1 is equal to this R1. Okay, this is your R1. This is your circle completed by the first surface. This is your circle completed by the first surface. Look carefully. Okay, this is the circle completed by the first surface. So the radius of this will be radius of curvature for first surface. So that is equal to R1. Okay, radius of curvature means the radius of this particular circle which is green in color. This is basically your R1. and the radius of curvature of the second surface. This blue circle which has radius of curvature equal to R2, this blue surface which has radius of curvature equal to R2. So this has basically what? This is basically the radius of curvature of the second surface. Okay, this is radius of curvature of the second surface. So R1 is equal to radius of curvature of the first surface, the radius of curvature of the second surface of the lens. Okay, A is an object on the principal axis of the lens. Let's see. A is an object on the principal axis. What is principal axis? This particular axis which has gone straight from the center of the lens. Okay, this particular axis which has gone straight from here, that is the axis AB. The axis AB is your what? Axis of the lens basically. Okay, so A is an object on the principal axis of the lens. So A is over here. A is kept on the principal axis of the lens. Okay. B is the image formed by the refraction of the paraxial rays. B is what? It is the image formed by the refraction of paraxial rays. So what is B? B is over here. Okay. It is formed by the refraction of paraxial rays. Now one of the rays we have taken same as the axis of the lens. So this ray will pass undeviated from the lens. Okay, this ray AB, this light ray AB, observe this light ray AB, this particular light ray. I am talking about this particular light ray. Okay, I am talking about this particular light ray. Okay, the white in color. So this particular light ray, you only tell me, it is passing through the axis of the lens. It is same as the axis of the lens. So it will pass by laws of refraction. You might have learnt in your lower classes that this particular ray which is corresponding to the axis of the lens, it passes undeviated through the lens. It passes undeviated through the lens as it is. Okay, and this is what this particular thing, this particular A and P, this particular ray, this is paraxial ray. Now what is meant by paraxial ray? If you have seen the previous lecture, then you must know the meaning of paraxial ray. This AP is a paraxial ray. As soon as I say that AP is a paraxial ray, I just mean that this theta, the angle theta which is over here, this particular angle theta, okay, this particular angle theta is very small. That's what I mean. Okay, this is very small, means like this. Over here we have shown it to be big, over here we have shown it to be big, but it is actually this very small angle. Okay, it is only in minutes. Okay, its angle will be in minutes or seconds, like that. Okay, you must know this very well, that angle is measured in degrees, minutes and seconds. Do you know this or not? So this paraxial ray means its angle will be within 1 degree or like that, something like that. Okay, not exactly 1 degree, but something like that. So it will be very close to the axis of the lens. It will be very close to the axis of the lens, and this AP gets refracted from this point P. This AP gets refracted from this point P, and these two light rays, this goes over here, and this light ray, paraxial light ray, goes from here till here, and then from here till here, and they both intersect at B, and an real image is formed at B. As a result, what happens? A real image is being formed at B. At point B, a real image is being formed. The point at which the rays actually meet, the point at which your refracted rays actually meet, the point at which your refracted rays actually meet, that point is called as your point of real image, and at that particular point real image is formed. So at point B, real image will be formed. Okay, and as I have taken the material surrounding this lens, this is the lens which you have, and the material surrounding this lens means this area and this area. All this area has refractive index n equal to 1, n equal to 1. We have assumed it for simplicity. We have taken air just for simplicity. Okay, so that's why n is equal to 1 for the surrounding medium. And for your lens, what is the value of n? We have taken it to be n itself. Okay, we have denoted it by n itself. Okay, A is an object on the principal axis of the lens. B is the image formed by the refraction of paraxial rays. Okay, this you understood. So this is the figure which you have finally with you. Yeah, now what is this u? U is equal to OA is equal to your object distance. Look carefully in this figure. This is your object distance u. Okay, this is OA. OA. This is what you will measure the distance of the object or distance of the image from the center of the lens. You will basically measure the object distance and image distance from the center of the lens. It is quite obvious. So this is your zero coordinate. Okay, this is your origin. So you are measuring this OA. OA will be what? Your object distance, because A is your point sized object over here which is kept over here. A is your object point sized object which is kept over here, and two rays are coming from this point sized object A. So these two rays, one of the ray goes like this and another ray goes straight from the center of the lens. Okay, so OA is equal to what? OA is equal to your object distance, which is equal to your U. Okay, and OB will be what? OB will be what? OB will be equal to V. OB will be equal to V, which is your image distance. OB is equal to V, which is your image distance. So OB is equal to V, which is your image distance over here. Okay, so this is the thing. A is an object on the principal axis of the lens. B is the image formed by the reflection of paraxial rays. We have learned this. And what is there? U is equal to OA is equal to object distance. V is equal to OB is equal to image distance. This also I told you. Now, according to Fermat's principle, what will happen? According to Fermat's principle, optical path APB equal to optical path AOB. Keep in mind APB. Okay, it is saying optical path APB. Okay, it is saying what? It is saying optical path APB. Okay, it is saying it to be equal to what? AOB. Okay, so optical path APB is equal to your optical path AOB. Now, how this has come? You know this very well, that out of the various possible paths for a light to travel between 2 points A and B, these two are what? These two are basically your two possible paths to travel from point A. See, this is your point A and this is your point B. Okay, so there are two possible paths to travel from point A to point B. Which two possible paths are there? This is one of the possible paths. A, P, B is one of the possible paths to travel from point A to point B, and A, O, B is another possible path to travel from point A to point B. Now you understand this very well, that your actual path followed by the light. Okay, this actual path followed by the light, both of these are what? Actual paths. APB is also actual path followed by the light, and AOB is also actual path followed by the light. So these are basically what? These are extremum. Okay, these are basically your extremum, and as these are your extremum, so what will happen? Both must be equal to same. Both must be same, right? As these are extremums, so both must be same. APB is equal to AOB must be there, because you only apply the common sense. You only apply the common sense. Suppose if a ray comes out from here at time t equal to 0, let's suppose a ray comes out from here at time t equal to 0 from A, and it reaches the point B at time t equal to 2 seconds, suppose. Okay, this is 0 second and this is your 2 second. Okay, while following the path APB, it gets launched. The light ray gets launched at 0 second. When the stopwatch timer was at 0 second, the APB path, it starts to travel. So it starts from point A, goes up to point P, and reaches the point B at time t equal to 2 seconds, suppose. Okay, and there is another light ray AOB, which has time 0 second over here, and when it reaches to B, it has suppose time 3 second. Okay, so do you think real image will be formed in this case? Do you think real image will be formed in this case? The answer is clearly no, because this APB is faster, right? APB is faster because it has only taken 2 seconds. So when AOB will reach over here at 3 seconds, this t equal to 2 second would have already come over here, somewhere over here. This t equal to 2 second ray, that is PB ray, might have come over here when AOB reaches over here. Okay, so if APB is faster than AOB, if APB is faster than AOB, then what will happen? Your ray will never meet at point B. If APB is faster than AOB, or if AOB is faster than APB, in either of the case, if they meet at point B, then it is quite obvious that these two cases are not possible. AOB cannot be greater than APB, or APB cannot be greater than AOB. They both must be the same. Why they both must be the same? Because only then the rays will meet at B. Only then the rays will meet at B. Otherwise the rays won't meet at B at all. Otherwise the rays won't meet at B at all. Okay. So just keep this thing in mind. So that's why your optical path APB must be equal to your optical path AOB. This is quite common sense fact from here. Okay. This is quite common sense fact from here. What happened to this here? Okay. Yes. So your path APB, okay, your path APB and optical path AOB both must be the same. Only then the rays will meet at B. Otherwise the rays won't meet at B at all. If they are meeting at B, that means that both must have taken the same time to reach from A to B. If the rays are intersecting at B and forming an image, that means that APB optical path is equal to AOB. Only then they will meet at B. Otherwise, if AOB is greater than APB, then why will they meet at B? Okay, one will be somewhere else and another will be somewhere else. Okay, they won't meet at all at that particular point. Okay, so your this thing is very clear to you now, that according to Fermat's principle, optical path APB is equal to optical path AOB. Okay, optical path APB is equal to your optical path AOB. You understood it right now. Okay, only then image can be formed. This, see over here it is written also. Only then image can be formed. Okay. Now, if the path APB is equal to AOB, okay, if APB is equal to AOB, let's write over here, okay, because APB is equal to your AOB. So from APB is equal to AOB, how this has come, how this particular expression has come? Let's look at the figure. APB, what will be APB? APB. So your APB will be equal to your AP plus PB. Okay, your APB will be equal to AP plus PB. Okay, this is quite sure, this is quite clear. Okay, your APB will be equal to AP plus PB. This is quite clear. Okay, so AP plus PB. Okay, now AOB, just look at AOB. AOB. Okay, so have a look at the expression which we have with us. AB minus CD plus NCD, N times CD. Okay, AB minus CD. Now what is AB minus CD? Let's look at it. AB. Okay, now AOB is the path. Okay, AOB is the path. This is straightforward path. Okay, so in this particular straightforward path, A to C distance. Okay, just have a look at it. AOB. Okay, what will it look like? It will be equal to your AC plus DB. Okay, these two are in air, right? AC and DB are in air. This is quite clear, right? AC, this part is traveled in air, and DB, this particular part is also traveled in air. What is traveled inside? Inside traveled is this much, which is traveled inside the lens. So when something is traveled inside the lens, then you write it to be N times CD. Okay, you know this very well, that optical path inside a medium, optical path inside a medium having refractive index N, optical path inside a medium having refractive index n will be n times of the optical path traveled in air. Okay, suppose I have n equal to 1, that is suppose I have air. Okay, if I travel 1 centimeter in air and if I travel 1 centimeter in glass, suppose the glass has refractive index equal to 2 and I travel 1 centimeter in both. Let's understand the meaning of this. Okay, let me tell you properly. Okay, suppose I travel 1 centimeter in air, then my optical path will be it will be equal to 1 centimeter only. But if I travel 1 centimeter inside a medium having n equal to 2, then I have traveled optical path equal to 2 centimeter. 2 into 1, that is equal to 2 centimeter. Because I have traveled in denser medium. So even if I travel 1 centimeter in denser medium, then it will be equivalent to 2 centimeter traveling of air. Okay, 2 centimeter travel in air is equal to 1 centimeter travel in a glass of refractive index 2. Got it? So that's the thing. So over here, that's why this expression has come over here, n times CD. Okay, so now you can basically manipulate all these things. See, AB minus CD is written. Okay, just have a look at it. AB minus CD. Okay, AB minus CD. Why it is written AB minus CD? You can write it to be AB minus CD. Now AC plus DB is what? AC plus DB is what? AB minus CD only. So you can write it right like this. Okay, you can write instead of AC plus DB, you might also write AB minus CD over here. Okay, so you wrote it. So that is the expression which you got over here. Okay, AP plus PB is equal to AB minus CD plus n times CD. Your APB is equal to AOB. So that's why. Now take CD common out from here. Okay, take CD common outside from here. So AP plus PB is equal to AB plus n minus 1 times CD, which is equal to your equation number 1. For the first surface, now let us understand the meaning of this. Now you got the equation 1, right? You understood the meaning of equation number 1. We have derived the equation number 1. So for the first surface, what will happen? Let's look at it. But let me have some water before that. So from here we are going to start. Okay, from here we are going to start. Okay, so we have derived one equation. Let's look all the things just after I take the water. Okay. Yes, welcome once again. So we had learnt up to here that equation 1 we had derived. Okay. So for the first surface, what is there for the first surface? Let's see. Where is your first surface? Just have a look at this. Yes. So this is your first surface. Okay. This is your first surface. So for the first surface, what does it say? PO square plus CO square. Let's see. PO square plus CO square. Okay. CO square plus PO square. What is it equal to? It is equal to 2R1CO. Now, if you do not understand this particular thing, okay, this thing has been derived in the previous lecture. Okay, already derived in previous lecture. When we were deriving the mirror formula, okay, when we were deriving the mirror formula, at that time we had derived this. Okay, so just go to the previous lecture and watch it. That although it was taught on tablet, that's why the experience might not be very good. Okay, it was taught on tablet, so experience might not be very good, but you will understand everything. Okay, so derived in previous lecture this particular expression, that why this PO square plus CO square comes out to be equal to 2R1 times CO for this particular surface, for this surface which you have over here. Okay, this surface, let me show you this surface. Okay, this surface. And similarly for this surface also we will have one expression for this surface which has radius of curvature r2. Okay, for that also we will have something with us. So what do we have with us for that? Okay, for the second surface it is written over here, a similar expression will come. Okay, for the second surface over here. Okay, but for the first surface let us understand how this h square has come. Now CO square almost tends to 0. This CO square almost tends to 0. Why? Let's have a look at this. This PO, okay, PO and this CO. But this CO square almost tends to 0. Why this CO square is being neglected? Because the lens is thin. The lens is thin. Lens is thin, so CD is thin. As the lens is thin, so CD is small. CD will be small because CD is the thickness of the lens, and the lens is thin, so CD will be small. CO is half of CD. CO, not a half of CD, but CO will be even smaller than CD. Okay, so as CO will be even smaller than CD, so if we take the square of some small quantity, if we take the square of suppose 0.1, what happens? If we take the square of 0.1, then even smaller quantity arises, 0.01. Square root of zero point 0.1 is what? 0.01, right? So square root of CO, square of CO will be, square of CO will also be small quantity. Okay, even smaller quantity than CO. Square of CO will be even smaller quantity than CO. So while writing the square of CO square plus PO square, while writing this, we will neglect this CO, okay, and we will consider only PO. So PO is your H, so that will be equal to your H square. Okay, PO is equal to H from the figure. So PO square is equal to H square, and this CO square we have neglected. This particular term you have neglected it. It is almost 0. Okay, so PO square equal to 2R1 CO. What is PO square? PO square is equal to 2R1 CO, and PO is equal to H, so H square equal to 2R1 CO. This is your equation number 2. Okay, and for the second surface, what happens for the second surface? A similar expression will come. Instead of R1, R2 will come. Okay, and we had CO with us. We had CO with us for this particular surface. For this particular surface, we had CO with us. So for this particular surface, correspondingly, this particular surface R2, correspondingly we will have OD. Okay, so similarly for second surface, H square equal to 2R2 OD. In the place of R1, R2 will come, and in the place of CO, OD will come. So you have two equations over here. This is your equation number 2. This particular is your equation number 2, and this particular is your equation number 3. Okay. Now CO value you can find from here, H square by 2R1, and DO is equal to your H square by 2R2. Okay. From here you can just take this to the LHS. So H square by 2R2. Just take this to the LHS, H square by 2R1. Okay. So these two expressions. Now CD is equal to CO plus DO. Have a look at the figure. Okay. Have a look at the figure. CD is equal to, CD is equal to what? Thickness of the lens, and thickness of the lens will be equal to CO plus DO. Okay. So CO plus DO. So CD is equal to your CO plus DO. CO is equal to this much, DO is equal to this much. So CD will be equal to CO plus DO. So in the place of CO, put this value. In the place of DO, put this value. Okay, so what will happen? It will come out to be something like this. H square by 2 will come common outside. H square by 2 will come common outside of this particular thing, and 1 by R1 and 1 by R2 will remain inside the bracket. So this is your what? This is your equation number 4. Now AP is equal to this much. Now how this has come? From Pythagoras theorem. From Pythagoras formula this is there. Now let us understand what is AP. What three terms are there? AP, AO and OP. Okay, AP, AO and OP are there. So AP, okay, this is your AP. AO, this is your AO, this is your AO, and this is your OP. Okay, so OP square, OP square plus AO square will be equal to AP square. Why? Because this is a right angle triangle. This is a right angle triangle. Okay, this is this particular triangle APO. Look at this triangle APO, this triangle. Okay, this is right angle triangle. So AP square will be equal to PO square plus OA square. Okay, so when you take the square root on both the sides, it will be like this: AP is equal to AO square plus OP square square root. Square root means power half. Square root means power half. Now AO is equal to your U square. OP is equal to H square. How? AO. Let's have a look at this. AO. AO. AO is equal to your U, right? It is equal to U. AO is equal to your U. So U square will come over there. OP. OP. So OP is H. So H square will come over there. Okay. H square will come over there. So just write it down. Okay. Just write it down. So U square plus H square, square root. Now when something is taken outside the square root, U square take outside the square root. So as soon as you take U square outside the square root, you get something like this. There should not be any need to explain this. There should not be any need to explain this particular thing. Okay. So you got this. Now H is small in case of paraxial rays. In case of paraxial rays, this H will be small. How? Just have a look at this. This H is the point at which the ray is getting refracted. Okay, so in case of this paraxial ray AP, this H height will be small. This height H will be small because our length is in itself small. Our length is in itself small, so that's why this H will be your small, which H is basically the height of the lens. Okay, half of height of the lens. Okay, height of the lens taken from the center of the lens. So as our lens is small, we are taking all these things for small lenses. So H will be your small in case of paraxial rays, and this paraxial ray we are considering to be refracted from here. Actually, this paraxial ray is refracting not from here, it is refracting from the extremity. This paraxial ray is refracting, it's getting refracted from the extremity. Okay, from this point. Although I have shown over here just for convenience, but this actually the ray goes like this: A P, P over here, and then over here like this. Okay, so from this P extremity, this ray is getting refracted. Instead of here, it is getting refracted from here. Just for convenience, I have shown it to be a little bit downside. Okay, so H is small. So in case of paraxial rays, what will happen? H square by U square. What will happen? H square by U square is much smaller than 1. How H square by U square is much smaller than 1? Because your length is small. Okay, just have a look over here. This is your U. This is your U. Okay, this is your U. From here till here. Okay, and the dimension of the lens are very small as compared to the distance of the object and the image. As compared to the distance of the object, the dimensions of this lens is very small, because we have taken the thin small lens. We have taken a thin small lens. So H will be your small. Okay, as compared to U, because object will be kept at much greater distance. When you have your spectacles with you, you look at objects which are at greater distance as compared to your spectacles height. Your spectacles are basically lens, and your spectacle is very small as compared to the door at which you are looking, or the laptop screen at which you are looking. That is your object distance. So that is much greater than the size of your spectacle lens. Okay, so how we have it over here. Okay, so let's look at this. So H square by U square is much smaller than 1. So this term, it will be much smaller than 1. Okay, this particular term will be much smaller than 1. So we can apply the binomial approximation this much. Okay, 1 plus x to the 1 plus x whole to the power n is equal to 1 plus nx. 1 plus x whole to the power n is equal to 1 plus nx when x is much smaller than 1. but this holds only when x is much smaller than 1. Okay, so 1 plus x whole to the power n is equal to 1 plus nx only when x is much smaller than 1, and our this h square by u square is much smaller than 1 over here. So this quantity is much smaller than 1 over here, so I can take this half in the multiplication. Okay, so by this formula, so AP is equal to u plus u into 1 plus h square by 2 u square. This is your basically equation number 5. Okay, similarly you can find for PB also. Okay, you found for AP, so you can find out the same thing for PB also. Okay, you found for AP, so you can find the same thing for PB also. For PB also, let's have a look at the figure. AP and PB are corresponding. Let's see. Okay, this is your AP. Okay, this is your AP. So correspondingly on this side correspondingly PB will be there. Okay, all things are same. Okay, only in the place of AP there is PB. So in the place of R1 there will be R2 because R2 corresponds to PB, and instead of U which corresponds to AP there will be V which corresponds to PB. Okay, so those are the substitutions which you make, and by the law of induction you will get the same thing. Okay, so this is your equation 5, and similarly without proving we can write PB is equal to V into 1 plus h square by 2v square. This is your basically equation number 6. Now just add AP and PB, AP plus PB. Okay, AP plus PB, just add these two. So you will get u plus h square by 2u plus v plus h square by 2v. Then h square by 2 common from here and here. H square by 2 common from here and here. As soon as you take h square by 2 common from there and there, u plus v is plus h square by 2 into 1 plus u plus 1 by v. Okay, this is the thing. So what happens is that after that this particular term u plus v comes out to be equal to AB. What is this u plus v? Let's have a look at the figure. U plus v, okay, u plus v means this distance from here till here. Okay, so u plus v is clearly equal to AB. Okay, u plus v is clearly equal to your AB. Okay, so you can write over there. So where is that term? Okay, so this is the thing which you get. Then just a second. Okay, u plus v. Okay, over here it is u plus v. Then what will happen? U plus v will be written as AB, just shown right now. Okay, just sometimes ago I showed you. Okay, just some few moments ago I showed it to you. This is your equation number 7. Thus from equation 1, what will happen from equation 1? From equation 1, have a look at the equation 1. AP plus PB value is this. Okay, what is this equation 7? This is basically your AP plus PB value, right? AP plus PB value is equal to this much. So your equation 1, what is your equation 1? Let's have a look at the equation 1. This was your equation 1. Okay, this was your equation 1. So AP plus PB is same over here, and in equation 7 also in the LHS. In the equation 7 also in the LHS we have AP plus PB, and in equation 1 also in the LHS we have AP plus PB. Okay, so the right hand side must be equal in both equation 1 and 7. In both equation 1 and 7 right hand side must be same. So these two terms will be equated. So this AP plus PB is equal to this much, and from equation 1 you have the value to be equal to this much. Okay, the one which I am highlighting with a laser. Okay, so these two terms are equal. Then AB and AB will cancel from here. Okay, after you equate 1 and 7, equation 1 and 7, so AB and AB will cancel from here. Then what will happen? Then you will get h square by 2 equal to this much. Then h square by 2 will also get cancelled from here. Then you will get something like this. Okay, which is your equation number 8. This is what? This is your equation number 8. Okay, from definition of focal length, what do you get? Now from the definition of focal length is defined how? How is focal length defined? Let's have a look at this. from definition of focal length means, suppose I have some object at infinity distance. Okay, I have an object at infinite distance. Then what will happen? The rays will come like this. For an object at infinite distance, for an object at infinite distance, rays will come like this, parallel to each other. Okay, so those will get refracted and will intersect at a particular point like this. Okay, this is the definition of focal length. That is when u equal to infinity, your u becomes equal to minus infinity. Okay, your u becomes equal to minus infinity, then you get something like this. Okay, so your u is minus infinity, then you get something, the object distance is equal to this, which is your focal length. Okay, this much. Okay, so this is your focal length. So from definition of this, from definition of your focal length, so when u equal to minus infinity, and you know this very well, why minus infinity? Why minus infinity? Because this direction, this is your origin. Okay, this is your origin, and the directions on the left side of this, the directions on the left side of this will be taken as negative. Okay, and the directions on right side of this will be taken as positive. Okay, so these will be taken as negative, the directions on left side. This convention you must be knowing. Okay, so as we move in this direction, I will take the values to be negative, and as I move in this direction, I will take the values to be positive. And my reference point is what is my reference point? My reference point is this center of the lens. Okay, so from definition of focal length, you get something like this. If u is equal to minus infinity, then v equal to 1 by f. Okay, and r equal to plus r2 and r2 r1 equal to plus r1. Okay, not plus r2, it is equal to plus r1. Okay, this is written accidentally. Let's see over here. Okay, this r1 will be equal to this green circle. Have a look at this green circle. Have a look at this circle. Okay, I let me highlight it by green. Okay, have a look at this circle. Okay, have a look at this circle, this particular circle. Have a look at this circle. So this circle, this is your first surface of the your spherical mirror lens. Okay, your first surface of the lens. Okay, so its radius of curvature will be equal to r1, and this r1 will be in the positive direction from rightward from here. Okay, and similarly your r2 circle will look something like this. Okay, r2 circle will look something like this. Okay, so R2 will be your leftward. R2 will be where? R2 will be your leftward of this O. R2 will be your leftward of O. Okay. So R2 will be taken as negative and R1 will be taken as positive. So by sign convention, okay, by sign convention, what do you get? By sign convention, this is not R2, this is basically your R1. Okay. So R1 will be equal to plus R1 and R2 will be equal to minus R2 by sign convention. And your focal length will be positive because it is a converging lens. Because it is a converging lens, so your focal length will be positive because your your refraction will be on the right side of this O. Okay, on the right side. So that's why focal length will be positive. And when it will be diverging lens, then focal length will be negative. Okay, why? Because it is diverging. It is diverging. Okay, so they will meet ahead of the lens. Okay, virtual image will be formed in that case. So that is a different case, but in the case of diverging lens, your focal length is negative, and in case of a converging lens, your focal length is positive. Okay, so u equal to minus infinity. Why minus infinity? Because object lies to the left side of the origin of the lens. Okay, origin means center of the lens. So from definition of focal length, u equal to minus infinity, then v equal to 1 by f, and r equal to plus r1, r1 equal to plus r1, and r2 equal to minus r2. Just put all these values in equation 8. put all these values in equation number 8. So as soon as you put all those values in the equation number 8, the equation 8 becomes something like this. In the place of v, in the place of u, I have put minus infinity, and in the place of v, I have put f. Okay, and all those things are as it is. Then your 1 by f becomes 1 minus 1 into 1 by r1 minus 1 by r2. Let this be equation number a. Okay, then what happens? With proper sign, equation 8 is written as, how equation 8 will be written with proper sign? Your object, okay, your object, that is u is over here, that is to the left side, so your u will be negative. Your v is means object is formed over here on the right hand side, so it will be positive, so v will be positive. Okay, your r1 will be, because it is like this, so your r1 will be positive and r2 will be negative. So okay, so r2 negative, r2 negative, okay, this negative sign has come, and r1 positive, so positive is there. Okay, so now you look at this equation a and this particular equation b. Okay, this particular equation b, this is your basically equation b, and that is your equation a. This is your equation a in the yellow box. Okay, so from equation a and b, if you compare equation a and b, compare equation a and b, you will get 1 by v minus 1 by u equal to 1 by f. This is your equation c. Okay, so see, a is equal to lens maker's formula or thin lens formula. A is equal to what? Where is a? A is equal to your lens maker's formula, okay, or thin lens formula. This is your equation A. Okay, and your equation C is equal to your lens formula. Where is equation C? This is your equation C. This is your lens formula. Lens formula. Okay, this is your lens formula. So in this way you have derived the two formulas, that is lens maker's formula or thin lens formula, and you have also derived lens formula. So keep these things in mind, and this derivation can also be asked as an application. This was what? This was basically application of Fermat's principle. This was nothing but this was application of Fermat's principle. Okay, this was application of Fermat's principle. Okay, now the applications of Fermat's principle are over. All the applications of Fermat's principle are done. Okay, now we will look at lens aberration in the next class. Okay, thank you very much. Jai Hind, Jai Bharat.